Hello, welcome back, guys. So now we're going to discuss the questions from the topic conduction. Okay. So the first of all, we can discuss the questions from section A. Ready? And questions which are selected from the topic are discussing now. So question number 5. It is related with your conduction. Okay. The question is that the molar conductivity of strong electrolyte. Choices are increases on dilution slightly, does not change with the dilution, decrease on dilution, depends on density of electrolyte itself. The choice is increases on dilution slightly, right? Yeah, because we already discussed the variation of a strong electrolyte in a graphical pattern, right? Yeah. So if you're decreasing the concentration, it is already discussed. If you're decreasing the concentration, which means if you are moving from right to left, what happens? Conductivity slightly increases. Ready? And the reason behind it, you know, it is due to the decrease in interionic attraction. Fine. Anyway, so the choice is 1. Increases on dilution slightly. Fine. Now our question is question number 8. Question number 8. Okay. This is a discussion from topic wise. Okay. So question number 8, the conduction of electricity through electrolyte solution is due to. The conduction of electricity through electrolyte solution. We know that electrolytic conduction is due to the flow of ions, right? So movement of ions in electrolyte. So knowledge based question and we already discussed it. So question number 8, the choice is 2. Okay. The choice of the question number 8 is 2. Moving to the next question. Next question is question number 13. Question number 13. The question number 13 is which of the following is not correct? So you are asked to find the wrong statement. Okay. So the first statement, that is molar conductance of a solution increases with the dilution. That's correct. Right? Molar conductance lambda m increases with the dilution. It is already discussed. And the next statement, that is equivalent conductance increases with dilution. We know that molar conductance and equivalent conductance have same kind of variation and it increases with the dilution. The third one is specific conductance increases with dilution. No, specific conductance means conductivity, and it is a conductivity or conduction in a unit volume. If we increase the dilution, the number of ions in that particular unit volume decreases, so that conduction decreases, right? So specific conductance decreases with the increase in dilution is the correct one. So the choice 3 will be a wrong one and your choice. So the wrong statement from the question is choice 3. Fine. Question number 14. Equivalent conductance of a weak electrolyte increases on dilution. Equivalent conductance of a weak electrolyte increases on dilution. That's correct. For a weak electrolyte, its equivalent conductance increases. Why it is increases on dilution means according to the Cold ratios law, right? Yeah. That is increases number of ions per unit volume. No. Increases molecular attraction. No. Increases degree of ionization of substance. Fine. The choice 4 will be the answer, right? According to Oswald dilution law, as concentration decreases, or which means dilution increases, degree of ionization increases. That's why equivalent conductance of weak electrolyte increases on dilution. We already discussed the reason, so the choice we can choose it as 4. The next is the variation of equivalent conductance of a strong electrolyte with the concentration is correctly shown in the figure. No doubt, the choice is 2. We already discussed the nature of graph. Whatever it may be, lambda m or lambda e, its variation with the concentration will be a straight line like this. Okay, fine. So question number 16 having a choice of 2. Fine. So the questions which are discussed is 8, 13, 14, 16. One more question is the 15 is the 16 already discussed, the choice is 2. 14 already discussed, the choice is 4. 15 the choice is 2, okay? Fine. 13 already discussed, what is the choice? Choice is 3. What about the 15? So it's a simple question, as dilution of an electrolyte increases. So dilution increases, what happens to specific conductance? Decreases. Fine, that's correct. Molar conductance decreases, no. Resistance decreases, no. No change in takes place in conductance. So as dilution increases, what happens? specific conductance decreases. That is the only correct statement. So the choice is 1. Now the question number 16 is over. Moving to the question number 17. 17 also from our topic. 0.1 molar solution of a monobasic acid. Monobasic acid means acid which can supply only one H plus. Okay, that is said to be a monobasic acid. Ready? So HA is a monobasic acid where A be any kind of anion, and H plus is the a term which represents the property of that particular acid. Since there is one H plus, it belongs to what? A monobasic acid. So, 0.1 molar monobasic acid at a specific conductance, or sorry, specific resistance, and the specific resistance of that component rho is given. Resistance of small r, rho, specific resistance, which means resistivity is given as small r. Fine, and its molar conductivity is. So, the concentration which is given as 0.01, which means molarity given as 0.01. What you are asked to find? Molar conductivity. Okay. And the rho, the unit is given in ohm centimeter. The unit of rho is given as ohm centimeter. Then what about kappa? You know that specific conductance is the reciprocal of specific resistance, and specific resistance is R. So specific conductance is 1 by R. Ohm inverse, centimeter inverse. Ready? So 1 by R, ohm inverse, centimeter inverse. So which equation we have to use? 1000 times of specific conductance divided by molarity, or 10 raised to 3 or 10 raised to minus 3. That is the only thing next we have to discuss. Okay. We know that the unit of kappa, which is in ohm centimeter inverse, then you have to use 10 raised to 3. If it is in ohm meter inverse, then you have to use 10 raised to minus 3. That's the only change. So there is 10 raised to 3 into, what about the kappa? Kappa is 1 by R divided by molarity, that is 0.1. Fine. Correct? Yeah. So 10 raised to 3 into 1 by R into 0.1, like this. So this one moving upward will be 10 raised to 4 into 1 by R, or 10 raised to 4 divided by R will be the answer. Okay. So you can choose the choice as 3. Choice is 3. Fine. What about the next question? The next question from this topic is 21. Question number 21. Fine. Question number 21 said that the specific conductivity of 0.5 normal solution is 0.01287. So the specific conductance is 0.01287. Ohm inverse, centimeter inverse. What are asked to find? Equivalent conductance. And the normality is given as 0.5. So you are asked to find equivalent conductance. And we know that lambda E. Since the unit is in ohm centimeter inverse, the expression will be 10 raised to 3 times of specific conductance divided by normality. So this will be 10 raised to 3 into 0.01287, right? Yeah. Divided by 1 by 2. Normality is 0.5, that means 1 by 2. Fine. So this one will be equal to 12.87 divided by 2. Sorry, 1 by 2. It will be equal to 24 cross 8. So 25 point something. Okay. So 25 point something into 10 raised to, sorry, 24 point something will be the answer. The choice will be third one. Ready? Choice will be third one. Fine. So moving to the next question. Next question that we have to discuss from this topic is moving to the next question, that is question number 22. What about the question? The question is, the specific conductance of saturated solution of calcium fluoride is 3.86 into 10 raised to minus 5 ohm centimeter inverse, and that of water used for solution is 0.15 into 10 raised to minus 5. The specific conductance of CF2 alone. So there is a saturated solution in which the solvent is water. Solvent is water, and with a specific conductance of 0.15 into 10 to the power minus 5. And the solution is saturated with the calcium fluoride, whose specific inductance, saturated with the calcium fluoride, and you are asked to find its specific inductance alone. Go through the question. And the specific inductance of this saturated solution is given. That is 3.86 into 10 to the power minus 5. So it is very easy that calcium fluoride and water combine to form the saturated solution. Okay, so the total conductance is 3.86 into 10 raised to minus 5, and the conductance of your water is 0.15 into 10 raised to minus 5, and you are asked to find the conductance of CF2 alone. So what will be the answer? It's very easy. And we know that the sum of conductance will be the net conductance. So if these two values are given, how can you find this one? 3.86 into 10 raised to minus 5 minus 0.15 into 10 raised to minus 5. That is 3.71 into 10 raised to minus 5 ohm inverse centimeter inverse will be the answer. Ready? Fine. So moving to the next question. That is, listen. What will be the molar conductance if X is resistivity? If resistivity is X, fine. Question number 23. What will be the molar conductance? So you are asked to find the lambda m. Okay. And the resistivity is X. And for a concentration of 0.1 normal. And 0.1 normal sulfuric acid, right? Yeah. Sulfuric acid. So you are asked to find the molar conductance. And we know the equation, that is molar conductance. What about the unit of resistivity? No unit mentioned. So simply consider it in ohm inverse centimeter inverse. Okay. Fine. So lambda m, the equation is 1000 or 10 raised to 3 times of specific inductance divided by molarity. So 1000 into 1 by rho into molarity. So 1000 into, and molarity we can written it as normality divided by n factor into rho. So 1000 divided by, what about the normality? That is 0.1 and the n factor is 2, right? Yeah. Into resistivity, that is X. So the equation will be 2000 divided by 0.1x. Is there any choice? Yeah, 2 into 1000 divided by x into 0.1. Right? So the choice, you can choose it as 2. Yeah, 2. Okay. Moving to the next question. That is the question from 24. Question 24. And it's a direct question. Conductivity at infinite dilution of ammonium chloride is given. Ammonium chloride 130, NaOH 218, NaCl 120, and if equivalent conductance lambda E of n by 10 solution, 1 by 10 normal solution of NH4OH equal to 10, then what you're asked to find? Degree of dissociation. Degree of dissociation. Fine. And we know that to find degree of dissociation, lambda divided by lambda 0, right? Lambda E divided by lambda E0. Equivalent conductance at that particular concentration divided by equivalent conductance at infinite dilution. Okay. So equivalent conductance at that particular concentration, 1 by 10 normal concentration, the equivalent conductance is given as 10. So the top one is 10. Now you want to find the equivalent conductance at a limiting concentration or infinite dilution of your NH4OH. For that, you are given with these three values. So it is very easy to find the limiting equivalent conductance of this one using this one. Because we need NH4 plus and OH minus, and it is in the first and second equation. So sum of the first and second, 130 plus 218, and you simply subtract the next. Okay, so this one cancel to form 10, and 228 will be the answer. So 10 divided by 228 will be the degree of ionization. 10 divided by 228. Okay. If you are putting this as 1000, you simply multiply here with a minus 2 and 228. Okay. If this is 250, you obtain a value more than 4. Sorry, a value exactly 4. Since it is less than 250, the value will be greater than 4. So 4 point something will be the answer, right? Into 10 raised to minus 2. So 0.04 something will be the answer. So 0.043. You can choose the choice as 2. Okay. Ready. So moving to the next question. Question is 25. And the question is that, listen carefully. The question is that the resistance of n by 10 KCl aqueous solution is 245. Resistance is 245 ohm. And the solution having a normality of 1 by 10. If the electrodes are of the cells are 4 centimeter apart, which means distance between electrode, you know that dimension L, distance between two parallel electrode L is 4 centimeter, and having an area, fine, area is given as 7 centimeter square, then the molar conductance will be, okay, we know that. Now to find the molar conductance, and this is KCl solution. 1 by 10 normal KCl solution where the N factor of KCl is 1, agreed? So 1 by 10 normal means it is simply 1 by 10 molar. So lambda m is fine. If these two values are given, you can very easily find G star, right? Cell constant, the value equal to L by A, and L is 4, A is 7. And this is in a centimeter inverse dimension. Ready? So the values are in centimeter inverse, so you can use the equation as 1000 times of kappa divided by molarity. And molarity, which is in the question 1 by 10, now you want to find kappa. In order to find kappa, we know that G star equal to kappa times of resistance, right? Yeah. Kappa times of resistance. Fine. So kappa will be equal to G star divided by R. So G star is 4 by 7 and R is in the question 245. And this is kappa. Now that kappa on substitution here will be 1000 into 4 divided by 7 into 245 divided by the molarity. The molarity will be here 1 by 10. Fine. And this will be here. So that is 10,000 into 4 divided by 7 into 245. And this one will be nearly more than 14. Because if it is 1000, it will be 4. Since it is 10,000, it will be more than 14. Okay. So 40 into 4, that is 160 or greater than 160, which divided by 7. If it is 140, it will be 20. So the remaining is 20 more than 20. So 43 will be the answer. I'm sorry, 23 will be the answer. 23. 23 is something. And there is only one choice regarding 23. So 23.2. We can choose the choice as 3. Okay. Fine. The next question, that is the question number 26. What is the question? For strong electrolyte, the values of molar conductivity at infinite dilution is given. So for some different strong electrolyte, the values of molar conductivity at infinite dilution is given. Okay. And if the electrolyte is BaCl2, then the value is 280 into 10 raised to minus 4 molar conductivity. Okay. It's in Siemens meter square mole inverse. Siemens meter square mole inverse, the lambda m. And that is for your NaCl equal to 1286.5 into 10 raised to minus 4. And that is for your NaOH is equal to 248 into 10 raised to minus 4. Fine. Then what is the question? The molar conductance of BaOH twice. Molar conductance of BaOH twice. Fine. So in order to find the molar conductivity of BaOH twice, you simply find the equivalent conductance of BaOH twice. And this type of question is discussed as a model in your previous section. Find the equivalent conductance of BaOH twice. Okay. Then, if equivalent conductance is given, then you multiply it with the n factor so that you obtain molar conductance. So BaOH twice, the n factor is 2, right? Number of OH is 2. That's why. Here the n factor is 1. Here the n factor is 1. NaCl 1. Here the n factor total number of positive charge, that is Ba2 plus and 2Cl minus. Positive or negative charge is 2. So here the n factor is 2. So if you obtain the equivalent conductance of BaOH twice, then you simply multiply it with the 2. You obtain the final answer. And here you are given with the molar conductance, right? So you can simply convert it into equivalent conductance. How you can convert? Molar conductance divided by n factor will be equivalent conductance. So equivalent conductance of BaCl2 will be 280 into 10 raised to minus 4 divided by n factor 2. That is 140. And all others have lambda m equal to lambda e because their n factor is 1. So only the molar conductance and lambda equivalent conductance is different for your BaCl2. So now you obtain everyone's equivalent conductance. So that is, you obtain the equivalent conductance of BaCl2 as 140 into 10 raised to minus 4 and equivalent conductance of NaCl as, tell me the value, 126.5 into 10 raised to minus 4, and equivalent conductance of NaOH also you obtain it as, tell me, 248 into 10 raised to minus 4. Now you need the equivalent conductance of this one, right? Okay. Now you can find. You need Ba2 plus and OH minus. So Ba2 plus is here and OH minus is here. So simply add this one and subtract this one. Okay. So 140 and all powers are same. So you can simply add and subtract and finally you put 10 raised to minus 4 there. So if these twos are adding, what do you obtain? Tell me. 248 plus 140. 100 is gone. It will be 388 into 10 raised to minus 4 and you are subtracting this one, minus 126.5 into 10 raised to minus 4. Okay. So 388 minus 126. What will be the answer? 2, 6 and 2. 26 is 2. So will be 261.5. You have to subtract 0.5 also. Into 10 raised to minus 4 will be the equivalent conductance. What it is? 261.5 into 10 raised to minus 4. And the molar conductance will be its double. And you know that the double of 261.5 will be 523 into 10 raised to minus 4. This will be the answer. The choice is 1. Okay. So the next question. Check the next question. The question that is in your section A. Question number 44. Question number 44. In this topic, okay? Which of the following solution have highest specific conductance? So, there are 0.01 molar. Let me write the all choice in a single version. All having concentration of 0.01 molar, and the first one is a weak electrolyte acetic acid, and the second one is also a weak electrolyte NH4OH. Third one is a strong electrolyte NaCl. Fourth one is also a strong electrolyte K2SO4. So it is very clear that for a particular concentration, the conductivity of weak electrolyte is less than strong electrolyte. So there is a chance for high conductivity for NaCl or K2SO4 because the rest are weak electrolytes. But NaCl can produce Na plus and Cl minus. So number of ions by that electrolyte is 2 only. But K2SO4 can produce number of ions of 3. And we know the factors that depends on conductance. That is number of ions per electrolyte and strength of electrolyte, like that. So comparing the strength of electrolyte, this will have a poor conductivity. So leave it. And this choose have a greater conductivity. Among that, the number of ions by each type of salt is entirely different. So from that idea, you can choose the one with the greater number of or greater specific conductance. So the choice will be one with the greater number of ions, moreover a strong electrolyte, that is K2SO4. Fine. So question number 46. 46. Fine. 46. The equivalent conductance of 1 molar H2SO4 would be, if its specific conductance is K is 26 into 10 raised to minus 2 Siemens centimeter inverse. What you are asked to find? Equivalent conductance. And the molarity? 1 molar. So we know that equivalent conductance, if the kappa is in Siemens centimeter inverse, that is 10 raised to 3 kappa divided by normality. So that is 10 raised to 3 into, what is a kappa? 26 into 10 raised to minus 2. What is normality? Here the molarity of H2SO4 is given. And you know how to convert it into normality. Normality is equal to molarity into n factor. Where the n factor of H2SO4 is 2. So 1 into 2. 2 normal will be the solution. So divide by 2. So this is cancelled, 13. And this on clubbing form 10 raised to 1. So this will be answer of 130. 130. But 130 is not in the question. And in the choice, so the answer is 1.3 into Siemens centimeter square equivalent inverse. So better to choose the choice as 1 because the choice 4 is Siemens centimeter square mole inverse. You are asked to find the equivalent conductance. So the choice will be in equivalent inverse. So the choice will be 1. Okay. Fine. So the next question in this section A, that is 55. Question number 55. The specific conductivity of n by 10 normal solution. Specific conductance of n by 10 normal solution is 0.0212 and it is in ohm inverse centimeter inverse, and the normality, that is 1 by 10 normal KCl. Fine. What is the next? And the resistance of cell contained in 20 degrees Celsius in the very same temperature, the resistance is 55 ohm. The cell constant. So now we are asked to find the G star. And G star, you know, kappa times of resistance, you obtain G star. So the kappa is 0.0212 and the resistance is in 55. Since this is in ohm in centimeter inverse and this is in ohm, this on multiplication, ohm inverse and ohm will be cancelled and the final result will be in centimeter inverse. Okay, fine. The choice is also in centimeter inverse. So what about this value? Let me write this as 212 into 10 raised to minus 5 into 55. So 212 into 55. 0, 1, 6, 10, 0, 6, 1, 0, 0, 6, 6, 1, 1. Into 10 raised to minus 3 centimeter inverse. So this will be 1.3 11 will be the answer, right? No. 0, 6, 6, 1. Oh, fine. This is 10 raised to minus 4. 1, 2, 3, 4. 10 raised to minus 4. Minus 4. So 1.166 into that much centimeter inverse. Okay. Ready. So choice is 2. Fine. So next question in this topic is next question from this topic is question number 59. Equivalent conductance of NaCl, HCl and CH3CON at infinite dilutions is given. Equivalent conductance of NaCl, lambda E of NaCl, HCl, CH3CONA are given as 91, 425.16, 126.45. What are you asked to find? Equivalent conductance of CH3COH. This is already discussed. So you require this one and this one. So add these two and subtract the above one. That is 91 plus 425.16 minus 126.6. That will be, I think, 390 point something. The choice is 389. Okay. You know how to add and subtract. So no worries. Choice will be 3. The next question, that is in section B. Now the MCQs from section B. Relating this one, okay? MCQ from section B. In section B, the question number 3. The molar conductivity of 0.5 mole decimeter cube. 0.5 mole per decimeter cube, which means 0.5 mole per liter, which means 0.5 molar. Okay. Solution of AgNO3. Okay, so you are asked to find the molar conductivity of AgNO3 solution whose electrolytic conductance or kappa is 5.76 into 10 raised to minus 3 Siemens centimeter inverse. So very easy. So lambda m is equal to, since it is in Siemens centimeter inverse, 1000 or 10 raised to 3 into kappa, that is 5.76 into 10 raised to minus 3 divided by lambda m, molarity 0.5. So this one and this one will be cancelled. Then the 5.6 divided by 0.5, that is 57.6 divided by 5. When dividing with the number, you simply choose the double of that number. 50, 50, 114, 115.2 divided by 10. So 11.52 will be the answer, I think. The choice is 2. Okay. The choice is 2. Fine. Next question in the section B. The question is 15. I think this is already discussed. Limiting molar conductivity of NH4OH. Which one is correct one? In order to get limiting molar conductivity of NH4OH, you require NH4 plus and OH minus. So you have to add lambda m NH4Cl and lambda m NaOH and subtract NaCl. So the choice 2 will be answer. So it is direct question, no need of writing. Question number 16 is not 17. Molar conductivity and infinite dilution. This is already discussed in the previous question, and the choice will be 4. Okay. The next question, that is 22. an increase in equivalent conductance of strong electrolyte with the dilution is mainly due to. So the increase in equivalent conductance of a strong electrolyte with the dilution is, and you know that that is a gradual increment, a slight increment, and it is due to the decrease in interionic attraction, right? So increase in ionic mobility of ions, 100% of ionization at a normal dilution, increase in both number of ions and ionic mobility, increase in number of ions. No, this is a strong electrolyte, so better to choose increase in ionic mobility of ions. So as dilution increases, interionic attraction decreases, so ion is more mobile, which means more having capacity for moving. So that will be the answer. Okay, question number 22, the answer is 1. Then, fine. 22, the choice is 1. What about 24? Which of the following expression is correctly represents the equivalent conductance at infinite dilution of Al2 SO4 thrice? Given that lambda 0 Al3 plus and lambda 0 SO4 minus are the equivalent conductance at infinite dilution. So lambda 0 Al3 plus means lambda equivalent conductance of Al3 plus and lambda equivalent conductance of SO4 minus are the equivalent conductance at infinite dilution. So it is very clear that in order to find equivalent conductance, no need of considering its number or ionization. Simply choose the cation and anion. So lambda 0 equivalent conductance of Al3 plus lambda 0 equivalent conductance of SO4 minus will be the answer, because you are asked to find the equivalent conductance, not molar conductance. So summation is enough. So the choice will be 2. Choice will be 2. Okay. Now the next question that we have to discuss from the topic section B, that is question number 28. Question number 28. What about the question number 28? Equivalent conductance of M/32 solution of weak monobasic acid is 8. So the equivalent conductance of M/32 solution of a weak monobasic acid is 8 mho centimeter square EQ inverse, and at infinite dilution. Okay, so equivalent conductance at a concentration of 1/32 molar of a weak monobasic acid HA is, so the equivalent conductance at that particular concentration is given as 8. And at infinite dilution, so the infinite dilution equivalent conductance is also given, that is 400. The concentration is, molarity is 1/32. So now you are asked to find the dissociation constant of that acid. And you know that dissociation constant is K, so K is C alpha square. Ready? So C into alpha square. What is alpha? Alpha is lambda E divided by lambda E0. That is 8/400. That is 2/100. 2/100. So C into, what is C? C the value 1/32 into 2/100 square. Okay. So 1/32 into 4/10 raised to 4. This is cancelled 8, right? Yeah. So this on top will be 10 raised to minus 4 divided by 8. What about the choice? That is a perfect figure, right? Yeah. So this on multiplication with 10 into 10 raised to minus 5. This can be written as 10 into 10 raised to minus 5 divided by 8. This will be 1 and the rest will be 2/8. 2/8 I think 0.125. 0.25. 1/4, 0.25. So 1.25 into 10 raised to minus 5 will be the answer. Is there any choice? Yeah. The choice is 4. Choice is 4. Okay. Ready? Again, we are moving to the next. So next one is something related to the statement of Kohlrausch's law. Question number 29. Kohlrausch's law states that infinite dilution, each ion makes definite contribution to equivalent conductance of an ion electrolyte. Of an electrolyte, whatever be the nature of the other ion of the electrolyte. Finite dilution of each electrolyte ion, definite contribution to equivalent conductance. Infinite dilution, each ion makes a definite contribution to equivalent conductance of an electrolyte depending on the nature of other ion of electrolyte. Infinite dilution, each ion of the electrolyte, for the choice at infinite dilution, each ion makes a definite contribution to electrolyte. So there is a chance for the choice of 1 or 3, right? There is no doubt, as we know that the Kohlrausch's law of independent migration of ions states that the limiting equivalent conductance of an electrolyte have a definite contribution by each ions present in that solution, and that limiting equivalent conductance that only depends on that particular ion, which means the contributing ion, and do not depends on the other ions present in that solution. Okay, so here you can choose a choice as 1, I think, because infinite dilution, each ions make a definite contribution to equivalent conductance of an electrolyte. Whatever be the nature of other ions. So whatever be the nature of other ions, then now consider here. Doesn't matter here. Ready? So the 29, the choice is 1. That equivalent conductance only depends on that particular electrolyte. That will not depends on the other ions present in that solution. Okay. So that is over. Question number 29 is over. The choice is 1. Next, question number 44. And this is a repeated question. And you know the answer will be 390. Okay. So the next, that is question number 47. This is also a repeated version. I think this is the question. I think the answer is 1.12. Is it? Here somewhere it is discussed. Yeah, question number 55. The section A. 1.166 is the answer. So in the section B, the question number 47. So 1.166. So 1.12 will be the answer. Okay. So I think the choice is 4. You check it. Okay. Question number 50. The equivalent conductance of Ba2 plus and Cl minus ions. Equivalent conductance of Ba2 plus and equivalent conductance of Cl minus ions are respectively 127 and 76. Then equivalent conductance of BaCl2 at infinite dilution. Equivalent conductance of BaCl2 at infinite dilution will be, since it is equivalent conductance, then the equivalent conductance of the ion Ba2 plus equivalent conductance of the ion Cl minus. Simply you have to choose the sum. 127 plus 76 will be the answer. So 127 plus 76, I think 3, 1, 3, 0, 1, 2. 203? Yeah. So the choice is 3. Okay. And there is no other question from this topic in your section B. So now the whole questions from the section conduction is over. So now simply I am dropping the section conduction. Now we want to discuss the next section, that is electrolysis.